excuse me, standards F4 and F5. We're going to start with F4, which is modeling functions. And when we're modeling functions, basically we are representing them in y equal mx plus b. So number 1, how can you write the equation for a linear function if you know only 2 ordered pairs? Well, we can do this in steps. Step 1, find the slope, which is m. Step 2, use the slope you found and one of the ordered pairs of point to plug into y equal mx plus b to find the y-intercept, b. And then step 3, once you know m and b, you can just write your equation in y equal mx plus b. Number 2 says a line passes through the point 2, -6 and has an initial value of 6. What is the rate of change? So it gives us this ordered pair, x and y. It gives us the initial value, that's b, so that is 6. And it asks, what's the rate of change? What is m? So I'm thinking about this equation, y equal mx plus b, where I'm given x, y, and b and solving for m. So I could just plug this into it. So I've got -6 equal m, my unknown, times 2 plus 6. So simplifying, I get -6 equal 2m plus 6. I want this m term by itself, so I'm going to subtract 6 from both sides to get rid of that term. I get -12 equal 2m. And then dividing both sides by 2, we get that -6 is m. Now this isn't a traditional type problem, but often we're using this equation to find b, but this time we were finding m, so it's a little different from our normal. Number 3, this problem is going to require some space to work this out, but we're going to write a function in the form y equal mx plus b for the line that passes through these points. This is going to use the steps we've listed in number 1, where first we're going to find slope, then use slope and a point to find b, and then write your equation. So I'm going to start with the first part of it, which is to find the slope. So m is equal to, we could do this different ways, but I'm going to use the slope formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You could use the table of values, which is actually a little quicker, and I tend to prefer that, but I'm going to use slope formula for our notes. So we have the first order pair, x sub 1, y sub 1, the second order pair, x sub 2, y sub 2. So y sub 2 is 21 minus y sub 1 is 5. Over x sub 2 is 6 minus x sub 1 is 2. So we get 16, divided by 4, which equals 4. So we know what m is. Now to go to the side and look at finding b. Step 2, we're going to find b. Let's use y equal mx plus b. And I'm going to pick an ordered pair. I think I'm going to pick this one for x and y. And we've got m is 4. So we've got 5 is equal to 4 times x is 2 plus b. Simplifying, we get 5 is equal to 8 plus b. I want b by itself, so I'm going to subtract 8 from both sides. We get -3 is equal to b. And then very last, we want to write our equation in y equal mx plus b. So we've got y equal 4x minus 3. Number 5, for each babysitting job, Adam charges a fee for his bus fare plus an hourly rate. The graph shows how he calculates his fee for a babysitting job. Write a linear function in the form y equal mx plus b to represent the situation. So I need to know m and b. So first of all, I've got b. b is 4. This is where it crosses the y-axis. Then I want to find m. So I'm going to pick a point on the line that I can clearly see, and I can clearly see this point where x is 2 and y is 14. And I've already got this point here where x is 0, y is 4, and I'm going to find the slope between those 2 points. So the slope is the change of y divided by the change of x. So for my y, from a y value of 4 up to a y value of 14, it increased to 10. For x, from an x value of 0 to an x value of 2, it increased 2. And 10 divided by 2 is 5, so the slope is 5. So the linear equation then in y equal mx plus b is y equal 5x plus 4. Number 10, what is the slope of this equation? 5x minus 2y equal 18. Well, I'm going to rearrange this into y equal mx plus b. So I want this term by itself. So I'm going to subtract 5x from both sides. And we get negative 2y equal negative 5x plus 18. And then divide both sides by negative 2. So y is equal to, let me point this out, negative 5x divided by negative 2 is a positive 5 halves, and that is x. And then positive 18 divided by negative 2 is negative 9. And then it asks, what is the slope? M. Well, m is 5 halves. Answer choice B. Number 11, what is the initial value of this equation? Y minus 3 equal negative 7x. Well, once again, I want y by itself, so I'm going to add 3 to both sides. And I could just cross them over the equal sign and change the sign. That would be the same thing. I get y equal negative 7x plus 3. And I want to identify the initial value. That's b. Well, b is 3. Answer choice C. Standard F5 is about describing functions. So looking at problem number 1, which term best describes the graph of y equal negative 5x plus 1? Well, really, we can look at the slope, negative 5, and see that it is decreasing. It's a negative value. Number 2, which term best describes the graph of y equal 25? In y equal mx plus b, this is like saying y is equal to 0x plus 25. Because we don't see the x term, we know that it's multiplied by 0. If it has a 0 slope, then it's just constant. It's just straight across. Number 3, the graph shows the height of a diver jumping off of a diving board as time in seconds increases. The height of the diver is increasing in interval 1. And in interval 2, it's decreasing. So decreasing in interval 2. Number 4, we're matching the types of graphs with the slopes. If it's a positive slope, then it's increasing. Decreasing would be a negative slope, and constant is a 0 slope. Number 6 describes a situation. We'll represent looking at it as a graph. An airplane takes off from the airport and steadily climbs to its cruising altitude. So we see starts out, then it gets to a cruising altitude, which is staying the same. About halfway through the flight, it hits some turbulence, so it descends a little. And we know that's about halfway, so it's going to continue to go straight across a while. And these should be straight across. They don't look perfect, but they're about going across. Then as it nears the airport, it steadily descends until it lands. Select all the terms that describe the height of the airplane over time for the entire trip. Okay, well, let's see. On this first segment, it is increasing for this first segment here. That's the only place it's increasing, but it also means it's positive there. We see some segments where it's decreasing. It's decreasing, choice B, right here and right here. We do see some segments where it's linear. It is linear in every segment here. There are no non-linear segments because it's all made up of straight line segments, and we're just describing parts of it.